Problem 29A on page 556 in the textbook says calculate the number of moles of each ion present in each of the following solutions. And so for part A, that's 10.2 milliliters of 0.451 molar aluminum chloride solution. So let's look at this problem here. We are given, here is a volume of solution, and here would be its molarity of aluminum chloride. And we are asked to find number of moles, and please notice this, that it's of each ion. So this is going to require an extra step from other molarity problems. Let's start with the definition of molarity. And molarity is moles of solute per liter solution. And in this problem, if we look back there, you can see we have a molarity, so we have that, and we have a volume. It's not in liters, but we can make that conversion. So we know those two things, and we need to find moles, which is what we were asked for. So if I rearrange that, then moles of solute will be the molarity of the solution times the liters of the solution. So let's look at those numbers. We do have a molarity. It's given in the problem. It's right here. So 0.451. And instead of writing the big M, I'm going to remember that big M actually is short for moles over liters. And then multiply it by the liters of solution. Now, our volume here is 10.2 milliliters. So we can do a real quick conversion here. If we remember that there are 1,000 milliliters in a liter, we could just move this decimal point over 3, and we'd have 0.0102 liters of solution. So 0.0102 liters of solution. The liters here will cancel out. And when we do that math, we will find we have 0.00460, and that's moles. That's moles of total solution, and that was aluminum chloride. Aluminum chloride. All right, so there's the number of moles, but this problem actually asks us to find the number of moles of each ion. So we're going to have to figure out what aluminum chloride does when we put it into solution. So let's go to a new slide here. When we put aluminum chloride in solution, it's going to dissociate into an aluminum ion, which is +3, and 3 chloride ions. Now, we calculated on the previous slide that the moles of aluminum chloride were 0.00460 moles. So, according to the balanced equation, remembering that there are understood ones in front of aluminum chloride and aluminum, for every 1 aluminum chloride, we're going to get 1 aluminum. So if we have 0.0046 moles, we will have 0.00460 moles of aluminum. Okay, so that goes along with that one. But when we put aluminum chloride into the solution, we will get 3 ions of chlorine, chloride ion. And so we're going to need to take this number of moles, and we're going to need to multiply it by 3. And when we do that, we're going to find that we get 0.0138 moles of chloride ion. All right, so let's just summarize the answer then. It asks us for the moles of each ion. We get 0.00460 moles of aluminum ion and 0.0138 moles of chloride ion.